Hello everybody. So I've kind of lost track of what live stream this is now at this point. I'm sure I could check on the YouTube channel, but I can't be bothered. Essentially what I'm going to be doing today is going through some to-dos that I've put inside of the code and just working through those slowly. So the reason I'm not doing this through the board is because the board cam is currently broken. It is here, but I had to dismantle the rig that it was set to. Basically, it was just a lamp that I had the camera strapped to, so that had to be taken apart so I could actually use the lamp for lamp purposes rather than as a makeshift camera boom. But yeah, the main challenge that I will be tackling today is this to do here, which is, as I've explained before, I'll try and show the board. We want to find the basically, we have a point in space in front of the camera where we're trying to place voxels, right? And we want to check the space between the camera and the voxel that line that point is at, and see if there's any voxels there. And if there are, we create a new point to select, basically. So the way that we're going to do that isn't quite clear to me yet. I thought I could do some research on stream and see if we come to any kind of conclusions. I suspect something to do with iterating through integers, maybe? So taking the floating point values of how best to explain it? So on a graph, on the X and Y axis, let's just take this 2D example for now because it's a bit more complicated than 3D. You can take the X and Y gradient for both, and then maybe we can use those so that every time... I don't really know how to explain it. I think what we do is just increase both, divide... Quite challenging. Let's see if there's any resources online. So I'll bring this tab across. I know what to look for actually. So this is essentially a raycast. So this hopefully should give me the gist of what I'm looking at here. So since the board cam is currently out of action, I am actually going to pull paint up again. So let's just hypothetically do this in 2D. The vector. Let's say this is vector 1-2. It basically is. Obviously this being point 1, this being 2, that being 1 up there. So what we essentially want to do is iterate through whole numbers along this point using these as increments. So what it seems to me is, we have a line going through a bunch of hypothetical boxes, right? And we either need to decide to go one level up or one level across. We basically just need to decide if we're going, like, what direction it is that we're going in. So the real question is, how do we do that? It's kind of a bit of maths that's on the tip of my tongue that I seem to remember doing a while ago. I think it was to do with pixel subdivisions, weirdly enough. It was like how to... that was it. Drawing a straight line to a screen based on a vector. Or we'll do it in voxels, because I'm sure there's something along those lines. Try it with pixels. Here we go, this is essentially what I need in 3D. Well, this is in 2D, but I need it in 3D. I think I understand what it's getting at, but I'm not entirely sure. So I think what it's saying is, basically, based on the gradient, we need to decide what increment we're jumping up in ones in. What axis we're jumping up in ones in. So my understanding is, in this instance, we're jumping up. For each pixel, we're going up by 1 through the layers, and then going across, we're just jumping in the increments that the gradient is providing for that direction, I think. don't know if this really makes much sense, to be honest. This is for dominant x-axis, is from what I understand of this. And then the slope is just the gradient of this line. Basically just going through every frame. Filling in the pixel. And then for some reason it's filling it in again. You know, I don't think we need this additional check. I think this would probably be less inefficient than just checking the line multiple times, to be quite honest, just running this for loop repeatedly, just incrementing every time. And it's kind of a lazy way to do it, but it should work. I think it might actually be more efficient in the end if I do it that way. I'm just basically trying to understand the problem as best I can before I start trying to implement anything. Because as soon as I commit to a solution, that's when things are going to get complicated. But if I can do a bit of research beforehand and find something that makes a bit more sense, then hopefully this becomes a little bit easier, because this is quite complicated at the moment. See if these links provide any other algorithms to use. Bear with me just 1 second. Just realised I need to double check the space free on this drive. Oh, I do have a bit of space free, that's good. Just so that the live stream actually saves, basically. See, I don't actually want this result because this does not take into account corner pieces, which is a problem. It's interesting to see the illustrations though. But yeah, that's not what I need, so I do need to use this algorithm. I mean, I guess I could try and copy the code in this, but I don't really want to do that. Especially since it involves another dimension. It's probably a lot more complicated than I think it is. Okay, this might be something, but it is very lengthy. Let's try and work out what it is that these guys are saying. Even if this is what I'm after. I don't know what this is trying to say. I don't know if this was the guy's native language or not, or maybe I'm just misreading what he's saying. Whether to visit the current voxel is a very strange question. It just seems worded kind of in a strange way. Right, taking the implementation before anyway, ignoring that. So in 3D, we have our little, it's not a straight line at all. We have our little line. In this case, I would obviously decide that the x-axis is the dominant axis since it's closer. So our vector would be comprised of 3 components. Let's say, just for curiosity's sake, it's 10, 6, and 3, whatever. Obviously this would be the biggest one, so this is just a simple compare. But because we're doing it in 3 dimensions, I don't know if we need to compare, if we need to choose 2 dominant axes or just 1, and then that it somehow works. But I would increment along. I'd increment along 10. By 1 each time. In this case, it would be 26, sorry, 12, 6, and that's a 12. And it would produce what kind of result? So let's say this was the case and here was the first one. Colour that in. Increment, it would colour that one in. And then it would colour that one in, so it'd actually be skipping out one. What if instead we chose the minor axis? I mean, it would be less efficient, but it would kind of work, I suppose. We'd never miss anything. This would also have to be normalised first, so that we get decimals, otherwise we'd be skipping over values, so we'd be skipping ahead to the 10th block. So that would translate into... oh, I've not picked easy number. Oh no, I have, of course I have. That's just 1, 0.6, and that's massive for some reason, and 0.3. So obviously this would still apply if we were... this graph's actually relevant to the normalised amount. But let's say we were to... yeah, so let's say we would stick with this. We would skip these corner cases. However, if we flip the problem on its head, and we did it using the minor axis instead, we'd increment by 0.3 along the axis each time. So this would be 1.3. I don't know what. I don't know what this would be, so I think it's proportional. But this would be 0.6. That'd go. It'd start here, go 0.3, 0.3, 0.3. But I think there's still a chance of it skipping. Yeah, so that in and of itself wouldn't work either. I still think some kind of if statement solution is actually best. So let's say we have a line, bunch of cubes, whatever, fairly standard as it has been. And okay, so let's say we're deciding what to do. We're obviously going in one of these three directions. We're going along one axis. So starting from here, this being our starting point. So like this is our starting point. We find out that it is part of this cube, so it's within this cube's bounding box. From that, we can determine that the line from this point is closer to this axis than it is that axis. And then we choose this as our new starting point. A really weird problem. I think the bulk of today's live stream is just going to be theory, as I don't actually want to be spending too long recording today. But what we'll do is we'll lay the groundwork today for hopefully finding an algorithm that's useful to us, and then we'll actually implement it in the next one. So what I'm going to do is see if I can investigate further this 4 connected line algorithm, and then see if I can do anything with it. Oh, I found a paper. Okay. Let's jump to the part where I get an answer. Not quite what I want because the line is not connected, I don't think. But I tell you what I do have. I have a maths book, so bear with me while I just see if I can find it. Not sure if it'll be in either one of these, but it should be somewhere. Let's have a look. That's semester 1, so I don't think this will have it in. No, not what I need. But this one on the other hand, so these are things I was given as part of my mathematics module, which have been quite good resources, if a bit wordy here. But if I can find it. I think I found it. So I think it's scan conversions. 73. Let's have a look. Well, I found the thing I didn't want, actually, which is the non-connected version. I wonder if there's a connected one. But at least I know what I'm looking for in terms of the name. So, line scan. Is this what I want? 3 scan conversion? But no, there's no illustration. Oh, yeah. Hopefully this has pictures. I like my pictures, not gonna lie. Let's see. In maths here, I just want an algorithm. Just didn't illustrate it, so I don't know if it's connected scan conversion or not. So if I can just find one with a connected example, I'm sure I can eventually. So so many pictures. Oop. It's actually part of the same article that I was just on. Again, doesn't tell me if it's connected or not. I don't think I can zoom in far enough to see. I don't think it is. Let me just double check one more time that I don't have plus for this. This has similar illustrations in it to the things that I've just seen on that other website. But unfortunately, I don't think it also has... I don't think it has connected scan conversion. I mean, that's just what I'm calling it. I don't know if that's the name for it, but basically I want chunky scan conversion. Maybe it's anti-aliased. Let's have a look. Do you have pictures? I need to see what the output is. If this proves too difficult, actually, I've just thought I could look into using ray casting in the engine to do it that way, as much as I'd prefer to do it using vector maths as like a kind of thought experiment. Might have to do it using built-in engine features, which would be fine, don't get me wrong. I would prefer to do it this way. I think it'd be more efficient. Because I'm doing it in voxel increments rather than straight line increments, which isn't what we need. So I basically need an anti-aliased algorithm. I search by image, it's possible I could find what I'm looking for first and then find the article it's attached to. Lots of articles I can't access. So from looking at this, and I've spent a lot of time this stream kind of looking in silence at various things, if I was to do it in a non-connected way, where these points aren't also considered, the most obvious thing to do would be to do this thing that I've said previously, where I jump along the dominant axis in bits, and then at this point see what voxel it's closest to. So basically convert the floating point number into an int, and that should give me the thing it's inside of, essentially. Might need to add 0.5 to the starting number though, just to put it in the centre of the voxel rather than at a corner point. Potentially, I'm not quite sure, I'd have to double check. What I could also do to make it connected is say, if so what I would guess to do is say if it's changed direction, so let's say it's changed in more than one axis. So let's say we were drawing this line here, and it was going in a straight line. We don't do anything. We obviously know that it's connected. But let's say it goes in two directions, so it goes on the x-axis and the y-axis. Then we look for the two closest points to this increment, and we fill both of them in. And I think that would work. We're going diagonally. Again, if it's in a straight line, fair enough. But then, if we carry on going, we jump by one again, and we decide that this point is oh, but then we run into a different issue. Oh, this is so complicated. Let's try illustrating this again and see if something clicks in my brain. I can maybe work something out. For some reason my drawing in Paint has gotten marginally better today. Not by a lot, mind you, like there, but a bit better than normal. So we need to know the second it crosses that boundary. Again, the second it crosses this boundary. A weird example. And then obviously it's further complicated by the conversion over to 3D. To be honest, it might not even be worth doing at this stage. I mean, it's a feature I would like to get done, but just looking at it from a time point of view, it might be something that I could just ditch for now. Put it on the back burner, but then I feel like there's quite a few things on the back burner that are nice things that are kind of optional, but I would like to get in as a polish thing. But again, it is like kind of polish, it's not strictly necessary. So what I think I need to do is I need to draw up a feature list, and every time I hit one of these that I'm like, I don't actually need to do it, but it is complicated. And it would be nice to have. I put it in a separate thing. So that's what I'm actually going to do. So I'm just going to make a document called I don't know, let's call it something simple, feature lists. What do I call it? Things that I want that this is actually based off of how I organise my diary, this must have, should have, could have thing. My diary has like must do, should do, could do. It's a nice way to break stuff down, so I think it helps you prioritise. And it has like three kind of levels of abstraction where Must-haves are stuff that's like absolutely essential. The should-have stuff is the good polished things that I'm talking about now, and the could-have is like the things that in an ideal world would be good to have in. So let's start by doing this. At the moment we've got vector line thing. So I'll leave the to-dos in here, just as notes to my future self, so I know where I'm working. So we know that we need to enable the physics system. That's a given. It's quite a broad category for now though, so I'm going to put that as a heading 2. And also this navigation pane is quite helpful in Word, by the way, for breaking down Word documents like this. I use it in development all the time, really good for organising data and stuff. I know it's not programming related, but quick tip for if you're ever having to do any project management or anything like that. But in anything, in fact, like it's helped me so many times when doing my essays as well, using these headings and using the navigation pane, that for some reason a lot of people don't do. But anyway, should have this would be goes on there. Is there anything else in the prop system that's essential right now? Oh, those will be normal, and I'll have heading 2, which is prop system. Same for down here. Back to normal. So over time I'll slowly be growing this list as things get put on the back burner and also things come into my attention as well. So I also need a fix for so I noticed there was a bit of buggy behaviour with the way props were getting removed. It didn't quite seem to be working properly, so I need to investigate that. We'll close that paper so it wasn't helpful, neither was that. This is close, but not quite. I think this is the link I need, so I'm gonna save this anyway. Stick that up there. Hopefully it'll be useful. Yeah, we'll leave that. So another bit of work we can do instead is, I have time to do it now. So no, I don't have time to do it now. I only wanted to keep this live stream short today, but throughout the week I'll be trying to do more to kind of catch up on all of the kind of live streams that I've missed doing last week, and also I want to get more development time in anyway, so it makes sense to do these more often. But essentially, yeah, I'm going to next time look at prop placement instead. Just getting the different types of props in. It shouldn't take long to implement, it's just a kind of menial thing and a matter of testing it and make sure it works. The complicated part is this voxel placement thing, which now that I've looked into it a bit, I think will be quite complicated. But at least I've got this list running. I'll save this on the desktop. So, there we go. close that. Okay, yeah, so sorry for keeping it brief and also not really getting much done in this episode. I know I'm not making a lot of progress from episode to episode at the moment, and I want to kind of start to change that as development goes on. Hit kind of a bit of a rut with programming. My other work's going really well in terms of article writing and getting these live streams at least finished, but the quality of the work is the quality of the programming work isn't going quite as well, so I'm not spending as much time on it. So I'm going to try and change that soon. But I kind of, for some reason, put off doing my live streams. Not 100% comfortable with them yet, but I am getting there. So the more I do these, and the more regular they become, the more I will be able to do high quality development, essentially, I think, as time goes on with this. And the quality will get slightly better over time. But that being said, thanks for watching again. Hope you've kind of got something from the process that I've followed so far. I know I've not really achieved anything, but sometimes that's just how it is. But yeah, thanks for watching, guys. I'll see you next time.